Okay, our last section of the review of the prerequisite course, exponential and logarithmic functions. We're going to develop and use properties of exponential functions, understand the definition of the number e, understand the definition of the natural logarithmic function, and develop and use properties of the natural logarithmic function. Properties of exponents. These are your exponential rules that you've been having for quite a few years now. Let a and b be positive real numbers and let x and y be any real numbers. A to the 0 is 1, a to the x times a to the y equals a to the x plus y. You add the exponents when you multiply the same bases together. When you take a power to a power for number 3, a to the x to the y, you multiply the powers. When you have a product to a power, you take each piece of the product to the same power. When you have a quotient, you subtract the exponents. When you have a power of a quotient, you take the numerator and denominator both to that exponent. And number 7, the negative exponent or the reciprocal exponent. A to the negative x means that is 1 over a to the x. It's the reciprocal of the number. Excuse me. Properties of exponential functions. Let a be a real number that is greater than 1. The domain of f of x equals a to the x and g of x equals a to the negative x is negative infinity to infinity. So either exponential function, the exponential function and its reciprocal exponential function, its domain, all the numbers you can plug in is negative infinity to infinity. The range, on the other hand, is 0 to infinity. The y-intercept of f of x equals a to the x and g of x equals a to the negative x is the point 0, 1. The functions f of x equal a to the x and g of x equals a to the negative x are 1 to 1. That means their inverses are also functions. So now, working with these three properties, we've got the definition of the natural logarithmic function, let x be a positive real number. The natural logarithmic function, denoted by ln of x, is defined as ln of x equals b, if and only if e to the b equals x. Note the notation ln x is read as ln of x, or the natural log of x. Excuse me, the properties of the natural logarithmic function. The domain of ln x is 0 to infinity. The range of ln x is negative infinity to infinity. The x-intercept of g of x equals natural log of x is 1, 0. And the function g of x equals natural log of x is 1 to 1. Properties of logarithms. Let x, y, and z be real numbers such that x is greater than 0 and y is greater than 0. When you take the natural log of x times y, that's going to equal natural log of x plus natural log of y. Natural log of x divided by y equals natural log of x minus natural log of y. And natural log of x to the z equals z times the natural log of x. Now, working with these, expand the following logarithmic expressions. Natural log of 3x squared y, it's product. So how do we separate when we're multiplying? We add them. So that would be natural log of 3 plus natural log of x squared plus natural log of y. We also have a product property here, that natural log of x squared, we can bring the 2 up front. So that simplifies to natural log of 3 plus 2 natural log of x plus natural log of y. On the next one, natural log of square root of 4x plus 1 over 8. First off, it's division, so we can separate it by subtraction. Natural log of 4x, natural log of the square root of 4x plus 1 minus natural log of 8. Square root is the 1/2 power, so we can pull out that 1/2, and also 8 is 2 to the 3rd, so we can do 1/2 natural log of 4x plus 1 minus 3 natural log of 2. Now, when we work with solving, basically we want to isolate the variable. If we have an exponential, we want to take the log of both sides. When we have a log, we want to rewrite it as an exponential. So natural log of e to the 3x minus 7 equals natural log of 2. Well, natural log is base e, and that's e to the 3x minus 7, so that's just going to be 3x minus 7 on the left, each equals natural log of 2. And we add 7 to both sides, divide everybody by 3, and we've got what x happens to be. That's an exact answer there. On part B, natural log of 6 minus x equals 3. Well, natural log is base e, so we could rewrite that as, and on the previous one, that's about 2.564. We can rewrite that as e to the 3rd equals 6 minus x. and then we can have e to the third and x switch spots, add x to both sides, subtract e to the third. So here we subtracted 6, divide everybody by -1. We end up with 6 minus e to the third is x, which is about -14.086.